Good morning. I'm just going to go hop through my section fairly quick. I manage the protection and the mitigation areas. These are the areas within ChemBio defense that are the most annoying to the warfighters out there. No one likes to wear their protective equipment. No one likes to clean up at the end. What we're trying to do is look at technologies to make that protection less burdensome, less logistically demanding, and as well as for the cleanup process to make it quicker and lower the logistical burden on that. So what I really want to do is focus on 4 different areas that I have challenges in and bring those challenges out to you to provide me answers for that. So the first one is respiratory protection. So we're getting at the point in our program where we're starting to think about the next generation mask. And if we're going to get into a next generation protective mask, it really needs to be a substantive improvement over what we have now. So how the warfighter has articulated this is a variety of different terms. One is rubber off the face. The other is reducing encumbrance. So let's roll with reducing encumbrance. And then on the slide, what you see over here is what that encumbrance might be. And so part of that is working with optical systems, firing your weapon. You see the Marine there firing his M4 carbine with a optical sighting system on there. Well, that optical sighting system is something the Marine Corps adopted recently that has raised the marksmanship by 25% in the Marine Corps. And if you've worked in the Marine Corps before, they really value their marksmanship. But when you put that sighting system on that M4 carbine and you put your mask on, it's a little harder to use and you don't get quite the same results. So the idea is, can I get that sight picture better on that rifle? Or if you look at the picture above that, which is the IVAS system, which is this heads-up display system that the Army is working on, that you can see an enhanced battlefield and get the data that you need to be a better warfighter. And can I interface that with the mask as well? So how do you do that? We have right now, with the current mask, 3 different sizes. So we try to take 3 different sizes and we can fit 95% of the military population out there with 3 different sizes. But it's very difficult to do that and also get that optical interface you have to get with all your other systems. So one potential solution is additive manufacturing. So I can have a bespoke mask that's more fitting my specific anthropometrics, and that I can get a better optical picture with my mask than I can if I'm trying to fit in one of 3 different sizes. So this is one of the different approaches that we're going to do, but what we're going to try to do between now and 2025 is come up with a bunch of different ideas to embody what is meant by reduced encumbrance. And so between now and 2025, we want to get as many concepts out there, whether they're drawings, they're tabletop things that you touch, or they're things that we can actually put on warfighters out in the field and test. And by 2025, we're going to try to down select those good ideas and start focusing on what a common view from the warfighter is of what reduced encumbrance means. So the next area, and so if you've pulled out your 2022 National Defense Authorization Act and you read it, there's a little section in there that tells us that we need to get rid of PFASs, the polyfluoroalkyl substances. So about 10 years ago, we knew that PFOAs, perfluorooctanoic acid, was being regulated, and that was the primary component that was the monomer that was going into these repellent systems that are on the protective garments. And you can see the impact it has on water rolling off and agents rolling off. And what the new NDAA tells us is that they don't allow those anymore, not only PFOAs, but anything that is a carbon chain that has a fluorine connected to that. And so this creates a big challenge. And right now there's a get out of jail clause in there that says if it has a specific a critical function, then you can still include that, but what that tells me in the S&T base is that we need to come up with alternatives. So the area that we're focused on right now for our alternatives are low-dimensional and 2-dimensional materials. And these are materials that are flat materials that can be used as coatings or additives to textiles or to surfaces that could potentially add repellency to that. So that's one potential approach, but we're looking at trying to find different approaches to that in the future. So the third area is regenerative materials. So if you're out there with a protective garment, the logistical process works as if the garment gets contaminated, you have to get a new one. So if you have any contamination out there in the battlefield, this could get logistically demanding very rapidly when you consider a chemical agent or biological attack can affect a large area. Even if the contamination is a very small amount, doctrine says replace it. So what we'd like to have is a suit that regenerates its capability without having to replace the suit. And at a minimum, at least get rid of the toxicological effects of the agents and antimicrobial effects on the pathogens. And so some of the materials that we've been looking at include metal organic frameworks, modifications that we've done to carbon, adding zirconia to that, and also developing antimicrobial materials. Not only are we looking at the material base, but we're trying to figure out how do you scale that. So we've been doing things in the past like leveraging funds from the Army for their manufacturing technology program, ManTech program, and currently we're looking at leveraging funds in the industrial base program that DoD has in order to take those materials and take them to a larger scale. But it's not just scaling those materials, you have to be able to take those materials and put them into a textile. And then once you have it into the textile, you have to be able to scale that to a roll-to-roll basis that it can be cheaply manufactured and put into a garment. So that's the challenge that we have, is developing those materials and figuring out ways we can reduce the costs of putting them in the garments and scaling up that process. So the final challenge area here is autonomy. So one thing I want to assure everyone here is that I'm not in the platform business. I'm not developing robots. What I'm trying to do is use the robots and the autonomous systems that the services are developing and leverage those. So right now we've latched on a system that the Army is developing under their SMET program. And so the vehicle there is the MUT. And that MUT is designed as a platform that's going to follow around light infantry units and also work as part of their resupply system that can go back and grab supplies and bring those supplies forward. So we're going to leverage some of the construction of the vehicle and the autonomy package that the Army has done on this and add to it a decontamination platform. And that decontamination platform would be a robotic arm that could pull up to the vehicle and decontaminate the vehicle. And so furthermore, we're working with Dr. Hannon's division on his efforts on digitizing chemical agents on the surface. So there's a technology out there that's in the process of being fielded called CBDS, and it's a spray you put on that will give you a colorimetric indication that the agent is there. So what if you can take that and scan that and then turn that into a digitized view that you can see on the two vehicles on the bottom there. You have CBDS visual in the digitize, and so it goes to the heads-up system, so no matter where that vehicle moves, you can see where that contamination is. And so we'd like to be able to leverage that activity to be able to pass that digitized information over to the robotic vehicle so the robotic vehicle can go out and find that contamination and decontaminate those specific areas. But the challenge here is also larger. So what you have right now for decontamination and doctrine is this thing called the deliberate equipment decontamination process. That involves the unit moving back into an assembly area, hopefully out of artillery range, and then a deliberate decontamination site being set up and the vehicles funneling through that and going to a post-decontamination assembly area at the end of it. And so it takes a long time. It brings them away from the front line. So what if we can get rid of the DED, just break that model completely and just simply have robots go out there to the forward units and do that as far forward as possible in a system that doesn't look like a DED at all. So what we'd like to do with this is, after we come up with this automation process, is perhaps develop a prototype decontamination, automated decontamination platoon that could be going through trials and we can understand exactly what this will look like and how it could be deployed in the future. So my final get off the stage slide is the sessions that I have in the main areas that we're going to talk in the sessions over the next several days. So with that, I'll pass it over to Dr. David Hone, and he's going to talk about medical.